Oh, we're nearly there, ladies and gentlemen. Nearly there. Oh, excited, excited. So, last two questions. Last two questions. Still on the sketching. We are looking to sketch h dash x. So what I would do is, first of all, remind yourself what we're doing. There's x, and this is dy by dx. I think that's the hardest thing to get your head around, is that this is no longer y. This is dy by dx. So this represents positive gradients. So if the gradient was 1, 2, all the positive gradients, so all these kind of gradients like this, positive gradients would be represented up here, and your negatives would be down here. That's the first thing. The next thing we notice that on this line, dy by dx is 0, isn't it? Dy by dx is 0 for a stationary point. So if we have a stationary point, that's where we're going to have a root on this graph. So let's come down then. There's going to be a root along here. I'll do it nice and bright and red because we've got a stationary point here. So I'm just going to write 0 in there. And we've got a point of inflection. That is still a stationary point. I'm going to have a root there. Then what we need to think about is, okay, is the gradient positive or negative? So here I've got positive, positive, it's all positive, isn't it? All the way up, and then it changes to negative, negative, negative. Again, these are 0. Ooh, but then it's negative. That's slightly different to what we're used to, isn't it? So let's have a little think. Before we get to this 0, I'm going to be in the positive zone. I'm going to be up here, positive. After that 0, it's going to be negative. But then it's going to be negative again. Interesting. So usually, before we've seen it where it's like positive, negative, something like that. This time we're thinking, oh, how do I get from up here to down there, back here again, passing through these dots? Now, the clue is actually in the question where it says that this is a quartic function, so it means that if that's a power 4, we differentiate that, we're going to end up with a power 3. If we've got power 3, we're going to have 2 turning points. So let's think then. I'm coming from up here. Okay, but I'll do this in a different colour actually. Do it in green. I come from up here, and then I'm going to have a turning point, and then another turning point, and that takes me back into there. That's your clue, was that there was going to be 2 turning points. If this was a cubic function, pardon me, you would expect to have 1 turning point, but this is going to have 2. So it's a wee bit tricky, that one, a little bit trickier, and just mark on your roots there as well. But I think, I'm not seeing the marking scheme, but I would imagine you would get a mark for knowing your 0 and 2, marking that on, and then trying to figure out your shape. Nice. Oh, I'm so tired. It's been quite a long. I hope you've enjoyed these videos. It's fun making them, but it's tiring. It's tough work. Last one then. Determine the values of P and Q. So this is very much looking at your roots. Remember the general form of a function. So you're looking for the roots, and the roots are going to form those letters. So if I was to look at a generic form, now this has got f of x. This looks like a quartic. So we're going to have 4 roots. So that'd be like k, x take away a, x take away b, x take away c, x take away d, your 4 roots. Now this one's 0, so that means your x just becomes, x take away nothing is just x, so you end up with kx. I've got a 1 in here, so that's going to be x take away 1, because we're changing this out. The root is 1, so that would give you a solution of x is equal to 1. So yeah, you change the sign effectively for the bracket. And the next bit, you'd be saying, well, I've got 2 roots there. So that's x take away 4 and x take away 4, which I can just write as x take away 4 squared. So for these ones, you're saying that, well, p is going to be 1 and q is going to be 4. So just remember that generic function. The reason there's 2 there, that's if it's a turning point on the axis, you've got 2 equal roots. So that's why I wrote that one out twice. Nice one. And then we've got find the equation of the tangent to the curve when x is 1. So this is our classic differentiation equation of tangent to the curve when x is 1. What this is wanting us to do is to differentiate. I'll leave that there. But no, I'll undo that, so I'll leave that. So it wants us to differentiate, but before we differentiate, we're going to have to say, right, my function is x take away, so it's x take away 1, x take away 4 squared. That k obviously is going to be 1 in this case. They haven't got another number in there. But that's our function, isn't it? The k is 1. So I need to multiply this out first of all. I can't differentiate that. So I'll just do this on the side. X take away 4 and x take away 4. This is how I like to uh, break out my brackets. So that's going to give me x. And I'll just do this bit first. That's x squared take away x. And that's going to give me x squared take away 8x plus 16. And actually, I'm going to change my pen. It's going off again. And to multiply them together, again, I would do the box method. I don't like doing the FOIL method. I much prefer this. It's so much easier to spot for mistakes, I think. Because the pattern's quite nice. So it's a negative, sorry, negative. So see how the patterns look quite good there. Be able to spot if you had a power out of place, 3, 2, 1, and then you can group the terms like this. You sound quite tired, don't I? A bit tired. X to the 4, and that's going to be take away 9x cubed plus 24x squared take away 16x. So the first thing we're going to do is we have to differentiate the function. I'm looking for the gradient at that point. So to get the tangent of the curve of x is 1, I'm looking to do point, gradient, and my equation. To get the gradient, I'll say that that is going to be f dashed x. So that's 4x cubed, take away 27x squared, plus 48x, take away 16. And into that, I will substitute my point of 1. So that's going to give me 4, take away 27, plus 48, take away 16. So for this, I tend to put my positives and negatives together. So that'll give me 52, take away 43, which is just going to give me 9. And I've got a gradient of 9. And my point, and substitute the point into the original function. So it's x is equal to 1. And this time, actually, I can make life easy, use this function. So that's going to give me f of 1 is 1 multiplied by 1 take away 1, 1 take away 4 squared. That's 1, sorry, 1 in there. So 1 take away 1 is 0. Let's double check that. Yeah, that must give me a y is 0 then. 1 times 0 just give me a 0. So my point is x is 1 and y is 0, and let's substitute that into the equation. So y take away b is equal to m brackets x minus a. So y is equal to 9x away 9. Oh, that felt hard. That was a long day, guys. It was a long day. So that's everything in the series. There's one question at the end that I won't go through. I'll do that later maybe. Looks like this is probably the biggest one in terms of working, which was our sketching the graph from nothing. So we had to get our stationary points. Like I said before, the first parts of the optimizations, do them at the end. Don't be wasting time doing them. But overall, if we think about where we started, this series of lessons, know how to differentiate. So work out your surge, your indices rules. Understand that stationary points occur when dy by dx is 0 and then you're factorizing. Understand that if you're asked about the equation of a line, you need to still do PGE, and the gradient comes from the differential equation. You substitute the point into the regular equation to get the y. That's quite a nice one. And for optimizations and for sketching graphs, you need to be thinking about your differential to work out where the stationary point is, but then the nature. So do your double differential or your nature table if that's what you like to work out is it a maximum or a minimum turning point. And that comes into the sketching as well. It's all about, is it a maximum, is it a minimum? Visualizing it, the positive, negative, positive, positive, negative, positive. But that really is all your skills. So know how to differentiate, dy by dx is 0 at a stationary point, and double differentiate for your nature. So thanks very much for listening, and I hope that was helpful.